Okay, it starts. So I hope that everybody can hear me. So good evening for European people, good morning and good afternoon for the other one. So my name is Xavier Vasques. I'm the IBM Systems Hardware technical leader for France. And the title of my topic is Infrastructure Design for Cognitive Workloads. Why is it crucial? So I hope that you hear me well, and I will share my screen now to share with you the presentation. So yeah, I hope it works. Okay, and the presentation is there. So recently, let's start like this. So recently, IBM CEOs Ginni Rometty publicly launched the emerging IBM as a cognitive solution and cloud platform company. And IBM Systems Hardware is at the heart of IBM's strategy by providing IT infrastructure designed and tuned for cognitive workloads, and also cognitive infrastructure itself built through open collaboration, accelerating technology breakthroughs. And my goal here in this presentation is to show you the importance of infrastructure for cognitive workloads or artificial intelligence. For me is quite the same, and developing and deploying machine learning algorithm at scale can provide significant and actionable insight to industries, especially when we are able to process a large amount of structured and unstructured data. And the most important is to take into account the right data system with performance, provide real-time insights, or assessing securely mission-critical data, correlate them with all the data we really need to provide, and this is the most important, not, let's say, developing the algorithm to stay in the desktop, but really to provide actionable insights. So artificial intelligence, yes, to do what? So we have this loop. When we look at the algorithm, we have this classical loop starting with learning, then transmitting and improving what we need to improve. And as any human in this planet, like Albert Einstein, he certainly started with physics for dummies, and he transmits his knowledge and then improve and discovers some beautiful things. So artificial intelligence can learn from a lot of things, can learn from expertise, skills, and knowledge coming from books, images, videos, scientific papers, everything. And data is really not missing today. Data flows from every device, replacing guessing and approximation with precise information. And in average, yet 80% of this data is unstructured. Therefore, invisible for people that doesn't know how to handle it, invisible to computers, and of limited use to the business. And some numbers just to see: by 2020, 1.7 megabytes of new information will be created every minute by every human being on the planet. And becoming a cognitive business start with a cognitive strategy. Of course, we need to determine what data you need, which experts you will train the system, where you must build more human engagement, which products, services, processes, and operations should be infused with the cognition, and which parts of the unstructured 80% of data you must need to focus on to make discoveries for the future. Then we need to build a foundation of data and analytics by collecting and curating is very important, the right data you own, data from others, data available to all, both structured and unstructured, apply to cognitive workloads, and apply cognitive technologies to this data in order to sense, learn, and adapt, thereby creating competitive advantage. And data is really the key thing, and is really transforming industries and professions. So, but the objective is to improve what your business, your profession, your skills and knowledge, and provide actionable insights. And I really like this word of actionable insight in any industry, such as finance, retail, healthcare, or science in general. And the world is being reinvented in code. Everything is code, and the building blocks for products and services today are code, and of course code, APIs, and diverse data sets. And the platform you choose to develop on, and the agile development culture and methods you embrace will be critical to your success. And the way we do is, for us in IBM, and what we believe is through hybrid cloud services optimized for industry data and cognitive APIs. When we speak about transmitting, we speak about systems like a car, systems tuned for cognitive computing. We need to architect a new kind of IT architecture, IT core, a heterogeneous infrastructure that serves as the backbone of an enterprise. And we can do this rapidly and affordably by harmonizing technologies from public, private, and hybrid cloud, everything communicating each other with distributed devices, Internet of Things, instrumentation, and existing systems. As cognition makes its way into cars, buildings, roadways, business processes, fleets, supply chains, securing every transaction, piece of data, and interaction becomes mandatory, essential to ensure trust in the entire system and in your brand and reputation. This is also one of the reasons why infrastructure is key, and I will describe it a little bit later on the next couple of slides. So let's take a well-known example of a system, the brain. I think this is one of the most well-known system in the world. And let's take some facts. The brain has a memory of more than 2.5 million gigabytes. He has more than 80 billion neurons. He has more than 100,000 billion of synapses, and it only uses 20 watt of power consumption. 20 watts. So it's a very small data center, but very powerful and consuming not a lot of energy. And this brain has non-cognitive abilities, sweating to keep cool, checking blood sugar, digesting breakfast, rising goosebumps, pupil adjusting to sunlight, tears forming due to pollen, adjusting breathing rate, lowering heart rate. So all of these things are non-cognitive abilities. But it has also cognitive abilities, of course, like perception, attention, memory, motor, and language, so the ability to express our thoughts and wishes with words and gesture, the ability to understand, interpret, and is the same for perception, with interpretation and recognition of sensory information such as visual, auditory, smell, touch. And of course, if the brain doesn't work as expected, we can see serious problem, unfortunately. And if it doesn't work as it has to work, the system is not more performant, it's sick. And such as Parkinson's disease, for example, involving shaking, rigidity, slowness of movement, and difficulty with walking, or Alzheimer's disease, a chronic neurodegenerative disease that usually starts slowly and gets worse over time. And the most common early symptom, and it's very well known, is the difficulty in remembering recent events, so the short-term memory loss. And it's the same for any system. If it doesn't work as it has to work, he's sick. And a cognitive system has to work, for example, at the speed of the brain. It has to be no more inanimate. It has to interpret things. If a system doesn't work, doesn't reach the expected speed, loses memory, has high bottlenecks, doesn't store the data in the right location, is not able to process all the needed data, to find the data, the system is not designed for cognitive business. And this is why we are entering in a new era with cognitive systems era, coming after tabling system and programmable systems era. And it is interesting also to see the evolution of artificial intelligence, and to put this in parallel. The word artificial intelligence appeared in 1956 with the objective to build systems to think and to act as humans. And this is a huge challenge. And this is why artificial intelligence also didn't work at the beginning. And another approach came with machine learning that came in the 70s with a more pragmatic and humble approach, with algorithms able to accumulate knowledge and intelligence coming from experiences without being guided in their own learning process, not explicitly programmed. But too early to really know in the 70s to really grow because of the lack of data and computing power. But this is not the same story today. And when we speak about cognitive system, it comes also with IBM Watson. So IBM Watson is a technology platform that uses natural language processing and machine learning to reveal insights from large amounts of unstructured data. And for people that don't know Watson, it's a computer system that was specifically developed to answer questions on the quiz show Jeopardy in 2011. And Watson competed on Jeopardy against former winners Brad Rutter and Ken Jennings, and Watson received the first place prize of $1 million. And today, Watson is a cloud-based open platform of expanding cognitive capabilities with Watson. With Watson, you can build cognition into digital application, projects, and operations. So it's available through cloud, through our development platform called Bluemix, and I invite you to check. You can access it for a period of time, and you can access Watson also to develop your applications. So since Jeopardy, it was in 2011, so now it's 5 years, and Watson has grown to a family of 28 APIs, and by the end of 2016, there will be nearly 50 Watson APIs with more added every year. And these APIs are underpinned by 50 technologies, and you can find a lot of very interesting technologies, of course, machine learning, deep learning, and language modeling, but a lot of things around visual analysis, visual rendering, voice synthesis, linguistic analysis, and things like that. And you can see here in the presentation. And these technologies drawn on 5 distinct fields of studies: big data and analytics, artificial intelligence, cognitive experience, cognitive knowledge. And one of my favorite parts is computing infrastructure with high-performance computing, analytics, distributed systems, programming models, and tools. So why infrastructure is really important for artificial intelligence and what we call cognitive workloads. The first thing is technology is the most important external influence among the C-suite today. And when you look at some studies, for example, you can see that 67% of CEOs feel technological disruption is making them reassess strategic direction. And 52% of global business leaders say that a substantial part of their revenue is at risk from technology shift. And digital transformation has led to the creation of a vast amount of data, and the digitized IT is working well, but it is time to do more by going beyond infrastructure. Analysis of data will lead to better insights, but studies show that most of this data is not fully exploited yet. And IBM sees the cognitive era as the next stage to automate exploration, discovery, and decision making based on this data. And organizations struggle with key technology challenges supporting insights, change, and speed. They wanted to understand data. Digital intelligence is a primary competitive advantage. And they want to keep pace with superior technology in order to deliver superior performance. And of course, one of the most important is to accelerate time to market. Sustainable success is now measured not in weeks, not in months, but in days. So our goal here is to reinvent the hardware and to help the IT leaders to be the architects of the future. The server and the storage are no longer inanimate. They can understand, they can reason, they can learn, and they can think. So the message is here is to outthink status quo, think IT infrastructure for the cognitive era. Because today it is possible to deliver real-time insight from oceans of data, move data to the right location based on usage pattern, detect anomalies to proactively resolve issues, and expose the systems, the systems you have through APIs to enable composable services. So IT infrastructure for the cognitive era means thinking differently about how you design, build, and deliver services. You have to design an infrastructure for cognitive business, meaning act at the speed of the brain, for example, gives meaning to unstructured data and can perform when the window of action is milliseconds. And building alone the technology is no more suitable. You have to build the technology through an open ecosystem, through collaborative and innovation to accelerate technology breakthroughs. So we have to take advantage of perpetual motion for what is still unknown yet possible with future innovation, and deliver through hybrid cloud. Extend the value of systems and data, extend existing business investments to integrate with the ecosystem and accelerate innovation. And cognitive computing and the new system era will be certainly the most disruptive in the history of IT, with systems able to learn at scale, reason with purpose, and interact with human features, which providing hypotheses, arguments, and recommendations. So it's really an important shift we have today. So what does it mean design for cognitive business? Behind the computing parts, data is transforming the applications in the industry with multiple format, information, life management, and security. And the predominance, volume, and importance of the data processed simultaneously by deploying systems, data analytics, and cognitive solutions makes the critical factor to design IT solutions with analytic acceleration and data-centric capabilities. Analytics acceleration in order to deliver the fastest insight with infrastructure designed specifically for complex analytics and machine learning. No more commodity. And data-centric design to capture the largest variety and volume of data while efficiently locating data and applications in the right place. So we saw in the loop, learn, transmitting, and improve right. So we have a couple of examples, and I will share with you, where we deliver groundbreaking research, faster cancer diagnostics, and real-time pricing model. And for example, for several customers, in one case, we allowed scientists to produce groundbreaking research faster by accessing petabytes of data in minutes, not in days, accelerate the sequencing of 3.5 petabytes of human genome data by a factor of 10 for faster cancer diagnosis, and created real-time pricing models to speed decision-making by increasing response time by 60. Several needs are critical, such as rapid access to data, low latency, fast storage, faster time to insight, compute infrastructure designed for big data, accelerated performance for complex analytics, machine learning algorithm. So it means you need hardware acceleration, and we work closely with, for example, NVIDIA and Mellanox, and power system with GPUs and accelerators to have this hardware acceleration, and also prevent data ingestion bottlenecks. And what we need is unified access to block, file, and object data at the same time. And of course much more, but I will not go into much detail. IBM has evolved its infrastructure and for example storage solutions to be able to scale to exabyte of data at terabyte per second speed to take advantage of the latest flash technology and transparently access a new standard format of data. So here you have a couple of examples, and this is why I'm telling you that hardware is also very important for cognitive workloads. We, for example, are able to analyze transactions in real time by executing scores in 2 milliseconds or less, so meaning at the speed of the brain. Increase analytic performance by 2.5 times with a balanced system design, delivering greater high bandwidth and memory and thread per core, so avoiding bottlenecks, and deliver IBM Watson retrieve and rank capabilities up to 70% faster. So the message here is when you have an artificial intelligence, you have to interact with humans, you cannot wait weeks or months to get a result. You need a millisecond in order to have actionable insights. We also build with collaborative innovation in terms of open source software, but also we open up our hardware. And a good example is the hardware side, and I will describe it on the next slide. So building with collaborating innovation means thinking differently about open technologies and choice. Innovating with open technology to deliver new solutions faster to market through community collaboration in support of a shared vision is a new vision for us. And you probably know that the Moore's law is the end of the Moore's law, and we need to find another way than just increasing the number of transistors. You have to look at the cores, at the sockets, at the IOs, at the motherboards, at the open source software optimized for this hardware. And there is optimizations to select the right platforms, runtimes, and deployment models required for this artificial intelligence workloads. And IBM started an open collaboration process through the Open Power Foundation. Open Power is an open development community using the Power architecture to serve the evolving needs of customers. So what does it mean? It means open development, open software, open hardware, collaboration of thought leaders, simultaneous innovation, multiple disciplines, and performance of the Power technology itself, trying to amplify the capability. So, for example, IBM and his partners like NVIDIA and Mellanox are integrating IBM Power processors, accelerated technologies, high-performance network, and hierarchic storage. And the computing challenge here is to improve real application efficiency and productivity while providing simple, standard, and portable programming models by sharing the memory between all the components, and especially by integrating accelerators as simple, extra specialized cores. One other example is Google. Google is a founding member of the Open Power Foundation, announced that is developing a next generation open power, and an open compute project form factor system. So Google is working with Rackspace to co-develop a server architecture specification based on PowerNough, and the two companies are working on that, and they are the freedom to improve the technology itself for their own needs. And this is not only the power technology, but also the mainframe technology. And the mainframe is also open to the open source. So, for example, Linux and open databases, and I will tell you a little bit later why. And also we have a new system called Linux One, is a full Linux system in order to unleash the full potential of Linux. It provides a portfolio of hardware, software, and services that combine the flexibility and agility of the open revolution with the industry most advanced, trusted, efficient, and performant enterprise system for business critical application. And the goal here is to really to put Linux at the enterprise level. And this is open. You can choose the tools and application you love. For example, the OS you want, like Ubuntu, SUSE, or Red Hat. Any hypervisor you want, databases like PostgreSQL, MongoDB, and this collaborative innovation with open technology is IBM is really investing a lot in ecosystems and open innovation. And one number that really shows this is that in 1999, we were 5 IBMers contributing to Linux and Apache projects. And last year, we were more than 50,000 IBMers contributing to more than 150 open organization. And you can see, for example, Node.js, OpenStack, Docker, and for example, also Spark. Spark is a good example. Spark works very, very well on these systems, on mainframe. And IBM has naturally taken interest in enabling Apache Spark as a first-class platform on IBM ZOS with an enterprise-grade solution to enable Apache Spark natively on ZOS, because much of the world's operational data are contained on the mainframe. And this is the paradise for a data scientist, who can assess all this data. This version really provides optimized data access to a broad set of structured and unstructured data sources through Spark APIs with the traditional data sources in a performance optimized manner with no data movement. And data scientists do not need to move data or only to take a small amount of data to build models, and they can perform advanced analytics without moving this data. And it's a key differentiator because often it's expensive, time-consuming, risky, and latency-consumer. The approach is no more going to ETL processes of copying mainframe data to other data lakes for analysis. So now we have a platform where you can get data from the bank, for colorate this data with social network data, interact with the customer and improve the client experience with, of course, machine learning and things like that. So this is really powerful, and I encourage you to see this some demos on Spark we have. So what has been collaborating with open innovation? So one more time with this loop, we need to improve. And this is clear numbers where we clearly improve. When, for example, we reduce the time to analyze the human genome from 28 hours to 26 minutes. So it's a clear advantage. And we also can see that we are over 10 times better data serving for MongoDB, MariaDB, and PostgreSQL. So the goal is really to put open source in this level of efficiency and performance. And we deliver through cloud platform. and hybrid cloud. And delivering through hybrid cloud means thinking also differently about security, about opening the systems and controlled iteration at scale. The ability to securely open up to enable partners to connect to your core system and data while enhancing security to mitigate the risk. And we have to be in control. Controlled iteration at scale to deliver microsecond performance and agile DevOps processes while supporting millions of users. So we have several technologies. I will not describe them, but here another what we improve. Seamlessly, we support up to 30 billion web interactions per day. And this is really important when, for example, we can do analytics in real time, in transaction analytics, and applied artificial intelligence, machine learning algorithm in transaction, and to have a direct interaction with a human and improve the client experience. We also can provide average response times of 30 milliseconds, supporting 50 million mobile transactions daily. And as I say, data is increasing, so we can scale up to 9 quintillion files and yottabytes of data for virtually unlimited growth. And this is just the beginning. What I describe here, and this is the last slide, is what we are able to do today for cognitive workloads. But we are also working on the future of hardware. And for example, one of the projects is the Synapse project, where we built a new chip called Synapse. It's a brain-inspired computer architecture powered by an unprecedented 1 million neurons and 256 million synapses. And it is just the largest chip IBM has ever built at 5.4 billion transistors and has an on-chip network of more than 4,000 neurosynaptic cores. And you know what is like the brain? We only consume 70 milliwatt during real-time operation. So the goal is really to be closer as possible of the brain and try to learn from the brain how the brain works, and then trying to define the new infrastructure, the infrastructure of tomorrow. And recently, IBM Research announced also for the first time ever, it is making a quantum computing available to members of the public. So you can access this. I encourage you to go to and type on Google quantum computing, IBM quantum computing, and try it. Try it, and you can access this and run experiments on IBM quantum processors through the cloud. So this is really important, and you can use IBM Cloud onto any desktop or mobile devices. So try it, and the other one is cognitive storage, where when I said that server and storage are no more inanimate, so now we want to build infrastructure that think. And here with cognitive storage, we introduced this concept, and it's published by trying to teach computers what to learn and what to forget in order to learn the difference between high value and low value data, meaning memories or information. And this is a differentiation that can be used to determine what is stored, where it is stored, and for how long. So thank you very much. I try to give you an overview of what is possible with the infrastructure and why it is important. And yes, key message is really design the infrastructure for your own needs. When you want to analyze tons of transaction and analyze in transaction with machine learning algorithms, and this infrastructure is by open collaboration, open source, and open hardware, and of course hybrid clouds. That meaning that we can connect the system through public, private, or hybrid cloud technologies. Thank you very much.